Hey, thank you. And I apologize to those that were kind of hanging around for um, information on the Intermountain Intertie. Uh, Lloyd is really the man to do that, John Lloyd, and he's probably built half of it himself and certainly maintains it, but he was so busy trying to get the VHF Society booklet out and get the repeaters correct. He was just swamped. He couldn't even feed me the information so that I could present it. So at some future meeting, I'm sure we can do that. Hey, I picked up this gadget. This is the NanoVNA H4, which is probably their second generation in production. And I'm going to talk about how to use it just as an antenna analyzer today. There's a lot more that it can do. Okay, let's start. Here we go. And got to put myself in there somewhere. All right, these are familiar antenna analyzers that if you've been a ham for any number of years, you probably had your hands on one of them or something like the MFJ. They've been around for ages. These are pricey things, and they are important to keeping your antennas up and going. Here's the top of the line rig expert for over $1,000. That's pretty amazing. The one I'm going to talk about comes up to $52.88 if you buy it from AliExpress. And they're also available on Amazon if you don't want to wait, and they're closer to $100 US plus tax. This has free shipping. And in my opinion, this is one of the best deals around because it can smoke many of the other antenna analyzers. So let's, that's the H4. What is a VNA? It's a vector network analyzer, and it's not this. This is a scalar network analyzer that I kind of cut my teeth on when I first got into RF engineering. It has a signal generator that sweeps a signal, and then this box displays it. And it uses these detectors to pick up different points. You can measure return loss or measure, like this looks like they're looking at a filter. These detectors are take RF and turn it into a small voltage. And the more RF, the more voltage, less RF, the less voltage. So here you've got very little voltage and it peaks and then it goes away again. And it continually sweeps. They had a lot of drawbacks, and I won't get into a lot of that, but let's move on. This is the first vector network analyzer that I used. Came out in 1980. This is the 8753C from Hewlett-Packard. Very, very popular piece of equipment. The A and B versions, not as popular, but they really cleaned up their act with the C version, and they sold bazillions of these things. And it has this arrangement of having these test ports where you can hook a device, an unknown device, we call it a DUT or device under test, between these ports, and it will characterize what that thing does, be it a filter, an amplifier, any kind of thing you put between here. And it does it with And the vector analyzers can't measure phase, they can only measure amplitude. And this does both amplitude and phase. And it can display it. It's not currently there, but it can display it as a Smith chart. And we'll talk about that just a little bit. But yeah, beautiful analyzer. Hewlett-Packard has upgraded. Well, it's called Keysight now. And this one runs, it's kind of bare bones, if you want to call it. The starting price is $239,000, and it kind of goes up from there. Not to be outdone by Roden Schwartz, they have always outclassed HP, but they've had the prices to deal with them too. I was showing Larry earlier before the meeting. I found one on eBay. A heck of a deal, $179,000. Okay. This is the NanoVNA, and this is the H4 version. And that's all there is to it, really. We're going to talk about that. And this is the later version that came out recently. It has 2 ports on the bottom instead of on the side. And these ports can optionally be turned into type N connectors, which are more friendly for lots of engagement, disengagement. And it looks like a nicer set of cables inside that came with. Very attractive pricing. This one will do from 50 kilohertz to 3 gigahertz, whereas my H4 will go from the same low end up to about 1.5 usable. You can put it up higher, but it's not really usable there. Okay. With that, let me bring up a video that I made in the last few days, and kind of an introduction to the VNA. So this is the NanoVNA. This is version H4, which I would call more of a second generation version. It comes with a complete case, which the first version was open on the sides. It comes with SMA connectors. They're recessed a little bit. I've put connector savers on, and I'll explain why in a little bit later. But okay, let's fire it up. Now, don't be intimidated the first time you fire it up and you see something going on and you don't understand. It's like, no, I'm just going to box this thing up and take it back. Forget it. I'm done. Well, all right, let's cut through the crud. First of all, we can turn on and off 4 different traces, and we can make them do one of about 10 different functions for each trace. Right now, purple is set for phase. We don't really need phase, so let's go to trace and turn purple off. We click once to select it and twice to then turn it off. All right, that calmed it down a little bit. Now I got this funny circly thing back here. All right, that's called a Smith chart for those not into RF engineering, and it's very, very useful. And I'm going to turn off trace 1. So if you look at SWR, this is at 1:1 at the bottom. It's currently set at 1 unit per division. So that's 1:1, 2:1, 3:1, 4:1, 5:1. So we've got 4 markers to play around with right now. Marker 1 is sitting at about 5:1 SWR, and you can move that marker around and it moves on all charts at the same time. Okay. The thing you need to do when you first get the unit is do what's called a user calibration. This is different than a full-on calibration by the factory, but even modern-day VNAs have to go through a user calibration. So before we do that, let's set up our stimulus. There. That's the signal generator inside. We want to set a start 50 kilohertz, which is the bottom end, and a stop 1.5 gigahertz at the top end. I think it was there already, but anyway, that's how you set the start and stop frequencies. Now, a couple other things. Let's go into config. Just this last upgrade that I got of the firmware, they added some really cool things. One of them is number of sweep points. So it normally was fixed at 101 points across the screen. Now I can select 401 points across the screen. The disadvantage is you get 1/4 the sweep time, but the advantage is you get a whole lot more resolution on every screen. Then, speaking of resolution, let's look again under display. They have a new option called bandwidth. And this used to be fixed at some unknown value. Now, this is the, they probably do it at the IF level, but this is the receiver, tuned receiver bandwidth. The narrower the bandwidth, the more precise your measurement is going to be, but you sacrifice time. So if I put it down at even 100 hertz, it takes probably 5 seconds per sweep. And if I went down to 30 hertz, it would go probably 15 seconds per sweep. Okay, we don't need that right now because we're not doing anything that precise. Let's look at calibrate. Now, calibration is done using these 3 guys that came with the kit. Oops, let's get it in the screen. And one of them, the first one is an open. It looks just like an O, O for open. We screw that on. While I'm doing this, let me explain a little bit about SMA connectors. For those maybe new to them, you've seen them on some of the Chinese radios, even, some of the Japanese radios are using SMA. Okay, we touch open. There's a trace, and open is done. It moves us down to short. But a lot of people don't realize that SMA connectors are not very strong. Those of you, I'm putting the short on now, those of you familiar with the Smith chart are watching the display change 180 degrees to the other side, which is what we're looking for. Okay, and we tap short and we give it a few seconds. The torque spec on an SMA connector is 7 to 10 inch-pounds. That ain't very much, folks. Now we put our load on. And that's for stainless steel, which you probably won't find very many. Most are a gold flashed brass. And for brass connectors, which is not as strong as stainless steel, the torque spec is in half. So you're talking 3.5 to 5 inch-pounds. What that means is when you grab your 5/16 wrench and put it on a connector, you want to get it barely past hand tight. If you can't take it off with your fingers, then it's time to stop. You're done. That's all you need. Torquing them harder, touch load, will only damage the connector and prevent its life. All right, now we are going to done. We have 5 different places to save this. I'm going to save in 0. Now with 0, that is the default when you turn the unit on. It will always go to 0. It will remember your setup. It will remember the calibration. A full sweep calibration is always best done stored in 0. We may not have to do any more calibrations. A lot of VNAs, when you change frequencies, change anything, you need to recalibrate it. This one is nice in that it interpolates between points. Okay, so we're sweeping up to 1.5 gig at we're at 400 points across the screen. So call it about 4 megahertz per point. So let's go back. If we changed our stimulus, let's say we just want to do the 450 band, 420 megahertz. And that's for start. For stop frequency, 450 megahertz. Now, let me give you the nickel tour of a Smith chart. The axis along the center, this is the only part on that chart that is pure resistance. Where it's sitting right now is infinite resistance, and where it's at the far end is 0 resistance. In the middle is our sweet spot, and for this Smith chart, it's normalized to 50 ohms. Anything above the center line is inductive. That's inductive reactance, and anything below, capacitive reactance. So by doing the 3 standard calibration, the open short load, some people call it SOL, we can see right now we did our calibration at the full bandwidth. Now we narrowed it down. Now we have 400 data points from 420 to 450. Okay, that's a whole lot less than 4 megahertz per data point. Let's put on the short. As I screw it on, you can see it draw down right to where it's supposed to be. If we remove it, at these frequencies, there's not much difference between the open standard and the open circuit without the standard. Very tiny phase difference there. And this is a 50 ohm load. Those 3 data points are the only ones that you need to calibrate. I wanted to show those familiar with the Smith chart that we were still calibrated even though we had changed our frequency range. This program, the firmware, knows how to interpolate between points very well. All right, let's turn off the Smith chart. Back, stimulus. And there are, you can print out a cheat sheet that goes through all of these menu items as to which goes to where. Let's take trace 1 off. Oops, trace 2 off. Okay, now we're just looking at SWR. We don't see anything. How come? Well, because we're looking at an open and it is greater than 10:1. So it's way off the screen there somewhere. So let's have some fun with this. I've got some SMA rubber ducky antennas that I really want to see what they do. Oh, we're at 450. Let's look at a dual band. Here's a Nagoya NA771. This is a 2 meter 440 antenna. The other thing with SMAs is you're supposed to only turn the nut. You're not supposed to turn the center pin as it's getting drawn up. But with some of these antennas, you can't avoid that. The center pin is supposed to just push in without twisting. But this one is locked, you can't avoid it. Okay, I'm going to keep this on an angle so we get a little bit of elevation to it away from my table and the metal tripod. Not too bad. That's 420 to 450, and it really favors the high end of the band, which is what I would expect it to do. All right, here's a trick. We can go back into calibration. We can say save, and let's call it number 1. Now, what did I just do? I just saved the 440 amateur band, the 70 centimeter band in memory 1. So anytime I want to test the 70 centimeter antenna or connection, recall 1, boom, you're set up. You're ready to go. Let's try another one. This one I picked up recently, actually, for my scanner. Let's do from 100 megahertz and stop at 500 megahertz. Something I wanted to show you, if I can do it without upsetting the antenna. This is a tri-band antenna. It's got a match down here in the 2 meter segment, a match at 220, another match up at UHF in the 440 band. And it actually works. So this is the Nano. Okay, I'll pause it right there. I'm gonna jump right into another segment, and we're gonna kind of transform into the backyard. And I apologize for the audio. The east winds were just starting to pick up, and so it kind of affected the audio a little bit. Here we go. All right, here we are in my backyard. I'm going to demonstrate the NanoVNA. By setting up a buddy pole, and we'll take a couple quick measurements. Let's target the 20-meter band and see if I can get some good results on that band. In the interest of time, I think we're going to speed this up a little bit. Okay, we're all set up, and here I've got a slight problem. My coax is BNC male, but the analyzer is SMA female. Fortunately, I thought ahead and brought my universal adapter kit that'll go from almost anything to anything. So we picked BNC female, one interconnect that it's common to all these connectors, and an SMA male. Done. Instant adapter. I tried to do this in the shade because I know in the sunlight, this is a little hard to read, unfortunately. I wish it had a little brighter display, but alrighty, let's set. I know you can't see this, but we'll go through the process. Start frequency of 20-meter band, 14 megahertz, and a stop frequency of 14.35 megahertz. All right, there's the 40-meter band. It's not bad, but not great. Is about 3-to-1 mid-band, 2-to-1, and up to about a 4-to-1 at the end, high end of the band. So we are too low in frequency. If we're too low in frequency, then that means we've got to reduce the lengths of the whips a little bit. Let's give that a shot. Again, I'll speed this up a little bit. And we actually went slightly too far. Right now, mid-band, I have a 1.5-to-1 SWR. The high end drops, it's about 1.5, but the minimum is up toward the high end of the band. And at the bottom end of the band, it's just about a 2.7. So if you're only working the upper end of the 40-meter band, 20-meter band, there you go. You got a tuned antenna. Sorry about that, trying to get things to work in the control room here. And let me move to indoors, where now I'll show you what I was able to see outside. This is what I couldn't show you outside because it kind of got washed out. The screen did a little bit. bottom end of the band is 14 megahertz, top end 14.35, and that's the middle of the 20 meter band. As you can see, it peaked up very nicely in the upper portions. So if you're going to be doing phone, that's a great match. But let's look real quick at one of the marker functions. We have 4 markers available. I have 3, and they have the frequency and their amplitude. Let's turn on marker 4, and let's do something. We can do a search for minimum. Marker 4 now jumped to 14.244, and it's got an SWR of 1.27. So just with one touch, we were able to find the sweet spot in the band. This is what I couldn't show you outside because it kind of got washed out. The screen did a little bit. Yep, didn't want that to start over. Anyway, handy little device. Take it out. I did get a better case for it. Got this off of Amazon for under $10, and it can slip inside these very easily. The cables and whatnot can fit in the top lid and it's got a nice protection between. Anyway, that's designed to hold one of those backup batteries for your PDA. So we've got this. The last thing I wanted to show you is we do have, let's do it this way. See if I can there we go. There is software that will allow you to, where can I go? Right there. One sec, I gotta move my face over. There we go. This will give you a lot more detailed information than what you can get off the screen of the NanoVNA. And it's unfortunately doesn't know that the Nano can go more than 100 points because that's what it programs it for. What's interesting is you can have several segments of 100 points each. So you can get 10 segments of 100 points across there. I'm waiting for them to update the software so that it can show more points, but that's turns it into a lab grade piece of equipment right here. So what else? Kind of summarizing, what else is this thing good for? Besides an antenna analyzer, the signal generator inside is good for something like 5 parts per million with a 1/2 part per million temperature drift. Very stable. Spectrum scope, you can use it for certainly sweeping filters, crystals, and other kinds. It probably doesn't have enough dynamic range to actually do a duplexer, but I'm going to look into that and see. And a function that is so fun is the time domain reflectometer, or TDR function that's built into it. That's got, I mean, tell you where your breaks are in your cable. Ever soldered both ends onto a connector and you hit it with an ohm meter and one of them is shorted and you don't know which one it is? TDR will tell you. Lots of fun things for that. So in summary, to use it as an antenna analyzer, turn off the traces you don't want to look at, set start and stop to the min and max that your unit is capable of, and you can set more data points and reduce the resolution bandwidth for a nice Then you do a full calibration on it, save it to 0. Now, all you have to do is throw it in a bag, keep it charged. I have it right here. Couple things I didn't tell you about. Number one, it charges with a USB-C port on the bottom, and that's how it communicates with the computer. On-off switch on the top. And it has, I never really use this much, but it does have a jog switch that you can use instead of the touch screen, but I just find the touch screen so handy, I never use that. So you set it up like that, put whatever frequencies you want to measure your antennas, and grab it and go. It has about a 5 amp hour battery in it, low voltage, of course, but I've ran it 8 or 9 hours and still had it functioning. The battery indicator on mine isn't working. I think it was a bug introduced in the last one because it still reads full. During one of my video sessions, the screen just went blank and it's like, what? And I had to go charge it up to continue, but so that's one thing that they're going to have to address. Now, it also, there's a nice little demo kit that you can order separately, and it has those little connectors on it, and it comes with a set of cables that have those kind of connectors, and you can connect it to that kit, and it has various things, filters, some band pass filters, and some high pass, low pass filters, and then pure capacitance. And anyway, it gives you a chance to play with this unit to see what it'll do. And that's actually what this is looking at. One of, this is the low pass filter. It's got a 400 megahertz 3 dB roll off point, and it's very shallow because it's only one section of a filter. But that's it. That kind of concludes my summary of this analyzer, and maybe in a future time we can get into some more fun things that it'll do. Anyway, I will turn it back to Larry.
Great. Thank you, Mike. There's a lot of information there in that presentation, and I really appreciate the time that you've spent to put that together. We often hear hams talking to each other, that especially talking to new hams, when they're asking where to put your money, it's often said to put your money up in the air. But if you don't have a tuned antenna, you're really defeating the purpose of spending that money and putting something really good up in the air, because you're just missing out on a bunch. So this is a great intro to an antenna analyzer. Does anyone have any questions for Mike? If you do, come off of mute and ask away.
Mike, David, K5BD, 3 short questions. Can the saved files be named or described? And the software, is that for the saved files? And finally, are those files downloadable? I'm thinking along the lines of, I have a problem, you're the guru, I download it, text it or email it to you, and you remotely tell me that I should take the straight pin out of the coax.
Yeah, what was your first question again?
Can the saved files be named or described?
Not on the unit itself.
Okay.
But I believe in the software, you can output S parameters in touchstone format, and I think you can save sweeps as well. If you look at the motherboard, it actually has a spot for an SD card to go in it. But it's not populated right now. Some versions have it, some don't. In either case, the case does not have an opening. So if you do have an SD card, you're going to have to grind yourself an opening there to access it. But yeah, that's coming, is actually being able to download a lot more information than what that can store.
Thank you. And the TDR capability, having used that on 2 different aircraft, F-111s and F-16s, I'm very familiar with the TDR.
Oh, you can't live without it once you have it.
Any other questions for Mike?
Yeah, Mike, it's Greg, K7UHP. Where do you get the software?
The software, there's actually a couple different styles. And this one is called, let me bring it up again. NanoVNA Saver is that currently up to about a 0.3 beta kind of software. All of this is still in development. The firmware for the unit coming out regularly with some amazing upgrades. There's also a NanoVNA QT, and I haven't played with that one much. I've only done this one.
All right, thanks.
And it's all free, open source kind of stuff.
Anything else for Mike?
Mike, this is John, K7JWL. How easy is it to upgrade the firmware on the device?
Not as easy as I would like. There is a program that you need to install on your Mac or PC or Linux machine, and then it runs from there over the USB-C cable and programs it. If you hold down this wheel while you turn it on, it puts it into a programming mode. They say that you can't brick it, it's impossible. And I've not heard of anyone doing that yet. So even if you mess up, you can do it again.
Mike, there's another variation of that as the tiny spectrum analyzer that is a separate, and for noise chasing, that sort of thing. It's a neat tool, and it's
Yes.
about the same price. So
I just saw that recently, and you know, I've got a spectrum analyzer downstairs, but yeah, at about 80 pounds, I don't think I'm going to go anywhere with it.
well, this one covers from 100 kilohertz to 350 meg or 240 meg to 960 meg.
Nice.
Awesome. These are great questions. I will ask Mike if you could put together a few links or that kind of thing to these different to the product itself, the NanoVNA, and to the software or anything that you think would be helpful. I'll be happy to put that on our resource page on our website. Also, Gary wanted me to remind everyone that the club does have an antenna analyzer that is available for checkout. And so if you're not in the mood to purchase one, we have one that's available that you can check out. But I think the most important part that I want to point out is that there is a lot of information today. But the best part about our club is that we have a lot of information collectively. So if you are getting to the point where it's time to analyze some antennas, you know, you've got something put up in your backyard and that kind of thing, and you want help, reach out to the club. and we will put a message out to members and see who's around and in your area and available to help. And without fail, we've always been able to find somebody to help each other out. So keep that in mind. Any final questions before we announce the winner of today's raffle?
Yeah, this is Kelly, KV7V. Can you hear me okay?
Sure can. Go ahead.
Yeah, I just had a quick question for Mike on sources to maybe, I understand, at least on the tiny VNA, there's been a lot of counterfeits. I imagine on the the tiny SA, I imagine on the NanoVNA, there might be that kind of problem as well. Do you have any information for, as far as, first of all, I guess a couple of questions. Is NanoVNA the manufacturer's brand name? And is there a legitimate website or a source for legitimate vendors of that, so as not to end up with a counterfeit or a clone?
Well, it all started, I'll give you a 10-second history of this, by a ham in QST around 2007, and came up with the idea. And then a couple years later, he and a couple buddies improved upon it and took it into the public domain. They made the PC boards, the parts list, even the programming on the processors, everything complete open source. So then some Chinese manufacturers took hold of that and built many copies of it very inexpensively. So it's hard. Tiny VNA is just a nickname per se, that they give it a product name, but it is not tied to any company. And I don't know how to tell the better builds from the lesser builds, and if there is such a thing, a difference in quality out there. I'm not sure.
Okay, maybe can you just tell us what the source for the one that you're demonstrating is? It looks like it's working.
Yeah, I got it from AliExpress, and you know, they stock anything and don't really do a lot of background checking on who's putting products out there. They just like to push products. So maybe I lucked out. I don't know. I haven't heard on the forums too much about people getting bad units, let's put it that way.
Great. Thank you, and great presentation.
Oh, thank you.
Anything else for Mike or for the general interest of the club? All right, hearing none. Once again, thank you, Mike. That was a fabulous presentation. I appreciate your time that you spent on that. It's something that we've been talking about in the club for a while, about antenna analyzers and how to use them. And so this was very timely, especially with us getting ready to go up to field day and that kind of thing. We want to make sure we've got stuff in good working order so we can have a lot of fun instead of chasing down a lot of problems. So that's great. So with that, we do have a winner of our drawing for today. During the presentation, my random name generator did its little thing, and our winner for a book from our bookstore is Brandon Rasmussen. So I will reach out to you via email and give you the list of what we've got, and then we'll figure out how to get those things connected together. With that, we do have another TechNet scheduled for next Tuesday. More information will be shipped out to you guys via the website, social media, and email about that. And field day information is posted on our website, along with the Feed Utah information and how to get a hold of Hall. So we've got those things going on. We would love to hear you on the air more often. So if you haven't been on one of the repeaters or an HF recently, I'd encourage you to turn on your radios and key them up and let's get talking and become radioactive. As we hear more, we will post it on the web and ship it out to you guys. But until then, we will see you at our next club meeting in a month. So I'll talk to you later.